So, function notation. We already know what a function is. We already talked about it. What is a function? A function is any mathematical expression with an input and an output that are independent of, unique to each other. Right? Excellent. So, the way we learn to write functions, we've learned 5 ways to show them. Graph, words, table of values, equations, and I'm missing one. Ordered pairs. Right? Okay. Function notation affects only the equation version. All right? So, if I write this, y equals 2x plus 5, you guys should be able to tell me a bunch of stuff about that. So hit me. What do you know about that? Excellent. I would multiply x by 2, add 5, and get y. Why did you say I would multiply x by 2, add 5 to get y? Why did you have to say it in that order, Sam? Close. Listen to what you said. I'm going to emphasize some of the stuff you said. You would multiply x by 2, then add 5 to get y. Why did you have to start with x?
Because
x is independent. X is the input, right? If I said, if none of this was here, and I said y is 7, could you tell me what x is? No. All right, good, excellent. So, everybody's cool with that. So we all know that that is the input. And once I give the input, I get an output. Right? Now, when you're faced with this, like you were in grade 9 many times, you immediately went to this situation. Right? And when I was a teacher, as I still am, I always throw some numbers in here. And my students always say, how did you know, Mr. Myers, to use those 3 numbers you put in the X? What is the answer to that question, Josh? Because it doesn't matter, because that's the input. You can put any numbers here and multiply them by 2, add 5 to get an output. Yes? So, I could put any numbers here. 7, 12, and 6. Perfect. No problem. So, if I input 7, what is my output? 19. Why is it 19? Because 2 times 7 plus 5 equals 19. What if it was 12? 29 and 6, 17. Is everybody cool? Now, the next question I will ask you is this a linear equation? And some of you will say, well, let's check. Plus 5 plus 10. Okay. All right. Well, what happens when I went from 6 to 7? Plus 1. And my y was plus 2. So that means for every 1 I go on the x, I'm going to go 2 on the y, correct? Well, let's check. So that means if I go 5 on the x, I must go double that on the y. Did I? 5, 10. Did I? Yes. So is this linear? Yes, even though it doesn't look like on the table. Right? Everybody cool with that? Okay, good. So everybody's comfy with this part of it, right? Gentlemen, your elbows are lovely, I must say. Sadly, you will never be able to lick them, but let us move on. You cannot lick your elbow. There are some freaks on YouTube that can lick their elbow, yes. But they are freaks. They have dislocated shoulders or they have abnormally long tongues. There are 7 billion people in the world. Obviously, there are people that can do stuff that you and I can't. The vast majority of the world cannot lick their own elbow. So, back to math. Everybody's cool to hear, yes? Yes? Okay. We know that once we write, I'm going to erase all these arrows here. We know that once we write those x's, how do we get the y's? What did we do? We did math, but what did we do with that x value? We wrote it out the first time. 2 times 7 plus 5, right? We input that value to our equation, correct? Everybody with me? Okay. Function notation uses this symbol, fx, which to say it in English, we read that as f of x. Okay? The f is the function's name. Everybody cool? Just like you guys all have a name, so I don't go kid when I mean Jashin. Understand? The reason we use this is because maybe there's more than one equation that I'm dealing with. So if I wrote out the equation, 2 equations like this, what's the output when x is 4? No. I want an output. You're giving me 2 numbers. What is the output when when x is 4? Can you answer that question? No, because these 2 functions have the same name. You do not know where I wish to input that 4. Does everybody understand? But if I change these and I gave them a name, the f of x equals x plus 3. Okay. And the g of x equals x minus 7. Now, do you know which one I am speaking of? So if I said the f of some number, would I be using the red equation or the blue equation? The red equation. If I said the g, would I be using the red or the blue? The blue. Everybody cool? That's all it is. So instead of x and y being input and output, x is still input, and this whole thing is now my output. Everybody good? All right. Let's build on that knowledge from grade 9, the way we used to write it, up to grade 10, the way we're gonna write it. Everybody cool? So let's start with this one. I have this equation. Because there's only one equation, I can leave it as y and x, can't I? Because there's no confusion about how I'm going to use this, right? Now, has this question given me some inputs? Indeed it has. Where do those inputs live, Nick? Where? In the table, under the x value, yes? So x is negative 2 according to this table, yes? So what do I do with that negative 2? I substitute it in as x, don't I? So my first one here is going to be 1/2 times negative 2 minus 2. Right? What is half of negative 2? Negative 1. What is negative 1 take away 2 more? equals -3, correct? Everybody agree? So that means when my input is -2, my output is -3. Because that equals that. Is everybody cool? Now, you guys do 0. When x is 0, what's y? -2. When x is 4, what's y? 0. Is everybody cool? I skipped 1 because that was going to leave you with a fraction and that causes you guys much grief. But it shouldn't be a problem, is it? What's half of 1? A half. Take away 2. -1.5. So everybody's cool, yes? And we can also plainly see that it is indeed a linear relation. Because when I went up by 2, I went up by 1, right? So that means if I go up by 4, I should go up by 2, shouldn't I? So when I went up by 2, I went up by 1. So if I go up by 4, I should go up by 2. Did I go up by 2? Yes. So it's linear. Is everybody cool? Okay. So you all knew how to do this, right? Right? So instead of y equals 1/2 x minus 2, we change it to f of x equals 1/2 x minus 2. And now, what do you think I would write if I wanted to use the -2? It would be the f of what? -2, which equals 1/2, not x, but when it's an x there, it's an x there. When it's a -2 there, what do you think is going to be there? -2 minus 2, which gets me -3, right? So in this notation, which of those is the x value? And which of those is the y value if I wanted an ordered pair? -2 and -3. Everybody cool? All right, let's see if you really are. Here is f of x. That looks really similar to a regular equation, right? So, I am asking you to tell me the f of 2. So instead of x, I need the f of 2. What happens? 2 times what? 2. Because I don't want the f of x anymore. I want the f of 2 minus 7. What is that? 4 minus 7, which is -3. Is everybody good? Now, what is the ordered pair that would answer that question? 2, -3. Right? Great. You guys do the next one. I now want the f of -3. So what do I write? 2. What goes here? -3. Then what? -7. What's 2 times -3? -6 minus 7. -13. What is the ordered pair? -3, -13. Is everybody good? I'm waiting for a moment. Everybody good? Everyone's good? No, don't stop. Don't. Go on. Is everyone good? Then prove it. F of 3 over 2. What do I write? 2, 3 over 2, minus 7. 2's on top, 2's on the bottom. What happens to the 2's? Cancel. What's left? 3 minus 7. What's that? Negative 4. So what is the ordered pair? 3 over 2, comma, negative 4. Is everybody good? Okay. Prove it. What is the F? What is the F of happy face?
Happy face equals happy.
Jack?
2 happy face minus 7.
2 happy face minus 7. What's the F of lightning bolt?
2 lightning bolt minus 7.
What is the F of 2x?
2x.
Prove it.
4x.
4x minus 7. Oh, you. Yeah. Okay, wait. You don't have to write these down because these are getting crazy, but I just want to see if you guys really understand. If the F of 2 is 2 times 2 minus 7, what is the F of 2x? We just did it. It's 2 times 2x minus 7, which would be 4x minus 7. Doesn't help us, right? Okay. What about this? What is 2 F2?
Everything, but at the end, it's 2.
Look at this guy. It's 2 times 2 times 2 minus 7.
Whoa.
Which would be 2 times 2 is? Minus 7 is? Times 2? Negative 6. Look at you, Jashin. All right, good. So everybody seems okay with this. I don't think you're lying to me for a change. All right. Uh-oh. Why are you doing it, Mr. Myers? Fractions. Why? Stay cool. I have a function. What are the inputs that I have?
6, negative 3, 0.
So the g of 6 would be what? Negative 2 thirds times what? 6. 6 is really what? 6 over 1 plus 1, right? It does matter because it's negative 12 over 3, right? Yes, of course, but don't. Jack. Negative 3. So what's the ordered pair? Because I'm telling you to graph it. 6, negative 3. So I'm going to put a black dot. Where is 6, negative 3? 2, 3, 4, 5, 6 to the right. 1, 2, 3 down. Excellent. Now, what's my next input?
0.
G of 0, which is what? Negative 2 thirds times 0 plus 1. 1. What's the ordered pair? 0, 1. 0, 1. Yes, Josh. What's negative 2 times 6? Negative 12 over 3 times 1. So negative 12 divided by 3 is negative 4, right? Negative 4 plus 1 is negative 3. Cool? Okay. And the last one? The G, oh, I wanted to do that in a different color, please, machine. The G of negative 3 is negative 2/3, negative 3 plus 1. What happens to the 3's? Cancel. What happens to the negatives? Negative times a negative. Negative times a negative. Positive. So the negative cancel out. So I'm left with 2 plus 1. What's that?
3.
So what's the ordered pair?
Negative 3,
Negative 3, 3. Negative 1, 2, 3, 1, 2, 3. There's my line, right? Now, the question becomes, do I connect the line? We've already talked about discrete and continuous data. Do I connect the line? No, it's not. Do I connect the line? I can sit here and look like this all day, and you guys will continue to change your minds. Talk to your neighbor. I'm giving you 5 seconds. Tell me if I connect the line or not. 5, 4, 3, 2, 1, go.
So the answer is 3, so it doesn't keep on continuing as you go and you connect the line, if you know what I mean.
No,
No?
I do not know what you mean. All I'm looking for is a yes or no here. Absolutely correct. No matter what number I choose, can I multiply it by negative 2/3? Can I then add 1 to it? So it is every single input forever. Everybody understand?
So you connect the line because every input has an output?
Yep. Everybody cool? All right, now I want you guys to look extraordinarily closely at number 4. What is different between there and there? The g of x hasn't changed, has it? So what I have is g of x equals negative 2/3 x plus 1, yes? Normally, I'm given an input, aren't I? But what am I given here? An output. The g of x is 7. So where do I write 7? Does it go in that spot? Or does it go in the whole spot? It goes in the whole spot. Why? Because the whole g of x is 7. So this is 7 equals negative 2/3 what? X plus 1. I don't know my x, do I? I know the g of x. I know my output. I don't have an input. Jack, what do I do in math whenever I have an equal sign and a variable? You isolate the x. You do algebra. How do I where should I start with my algebra? The 1 or the 3 or the negative 2? The 1. How do I get rid of plus 1? Minus 1, minus 1. So now what do I have? 6 equals negative 2/3 x. Now what? You could divide by negative 2/3, but very few of you can do that in your head. So go step by step. It's not 4. How do I get rid of this 3? It's already dividing. Multiply by 3. If I do something to this side, what do I do to this side? Oops. 3. Now what do I have? 18 equals negative 2x. How do I get rid of times negative 2? Divide by negative 2. And what is x? X equals negative 9. So what is my ordered pair in number 4? Negative 9, 7. Now let's check. Negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Up, 1, 2, 3, 4, 5, 6, 7. Is it on the line? Ta-da! Everybody cool? Great. Let's see if you really are. I have a new function. It is function m. M of x is this, but I don't want the m of x. What's the first m that I want? 7. X is now 7, so what do I put in instead of 7? Instead of x here? 7 plus 2. What is 4/3 times 7? See how I'm getting double duty here? I'm making you practice your fractions too. That is 28 over 3 plus 2. Barf! 28 over 3 is really 9 and 1/3, isn't it? What's 9 and 1/3 plus 2? 11 and 1/3. So what is my ordered pair? Nicely done. What's the next one I want to do? The m of 1. So that is 4/3 times what? 1 plus 2. What's 4/3 really? 1 and 1/3 plus 2. So what's the answer? 3 and 1/3. So what's my ordered pair? 1 and 3 and 1/3. Is everybody cool? What's different in the last one? I need x. So it's not m of, it's 5 equals what? 4/3 x plus 2. Solve it. What do I do with plus 2? Minus 2 minus 2. 3 equals 4/3 x. How do I get rid of divide by 3? Times 3. 9 equals 4x. How do I get rid of 4? Divide by 4. What's the answer? 2 and 1/4. So what's my ordered pair? Whoa! 2 and 1/4. 5. Sweet. Now, some of you are going to argue with me. You're going to say, Mr. Myers, it's too hard. I don't get it. But the thing you're not getting is the fractions and the algebra. The function is no problem. Right? So if you are at a point where you're having trouble with the algebra or the fractions, who needs to take some responsibility for themselves? You guys. So, do I have a new function here? It is h of x now. What is the first function I want? H of 2. It's not h of x. X is now 2. So what do I write now? What do I write now? 2 minus 4. Tasha, the x is 2 now, right? Great. What is 1/4 times 2? 1/2. But there's a negative, right? So it's negative 1/2 minus 4. Negative 1/2, and I'm going further negative. Jack?
It's 4.5.
Negative 4 and a half. What is my ordered pair? 2 and 4 and a half. Wait, Jack. What is this h going to be? Negative 2. What is this? 1 half minus 4, which is what? Negative 3 and a half. What's the ordered pair? Negative 2 and negative 3 and a half. Everybody cool? What's different on the last one? I don't know the x, so it must be negative 4 equals what? Negative 1/4 x minus 4. How do I get rid of minus 4? No. You add 4 to both sides. 0 equals negative 1/4 x. What does x have to be for this to be 0? Guys, 1/4 times what will get me 0? 0. So what's x?
0.
So what's my ordered pair? 0, negative 4. Is everybody cool with the algebra way to do it? Right? It's just substitution. You've done it to death. A squared, b squared, c squared is this. Everybody cool? All right. Now, you guys are smart kids. You're aware that we also can graph functions, right? What is a graph made up of? Numbers that are all x's or y's, correct? So if functions are made up of x's and y's and graphs are made up of x's and y's, we should be able to work it out, shouldn't we? All right. The curvy one is f. The straight one is g. I want to find a value on which? On the curvy one. Now, f of negative 3, is that an x or a y value? That's an x value. So where would I find an x value of negative 3 on the curvy guy? Where is the x value negative 3? Right there. There's my input. How do I find my output? I go to the line where the line is. That is the point that has an input of negative 3. What is its output value? Negative 2. Does everybody see how it works? Great. You tell me the g of 0. Is that an x value or a y value? It's an x value. So I go to 0. Now I need to find my output on the straight line. What is it, Nick? 2. Right there. Holy Toledo.
Holy macaroni. Holy macaroni.
Okay, what's happening here? What's happening in C? So I found negative 2 on the x, but that's only an input. The output is negative 3. Oh my good gravy. Can everybody do that?
I did just now.
Everybody can?
Oh, the board.
Well, just wait. What is the f of negative 4?
That's negative. Oh, 1.
1. Excellent. What is the f of 1 half? Killing me, Smalls.
Negative 2, I think.
The f of 1 half.
What value?
So where is 1 half? On the x-axis. Tell me where to go to find 1 half. Right or left?
In the middle of 1 and 2.
To find 1 half?
Wait, right.
I want a half, not 1.5. I want a half.
Oh, okay.
Why did I think
From the negative 0, 1.
So right to there. And then what?
You go up.
Or down.
And what do I get?
3
A little bit more than 3. Cool? All right, good. Now, let's reverse things. How is D different from A, B, and C? The f of x is 1. Is that an x value or a y value? That's a y value. So where do I go to find it? On the y-axis, right there. What is the x value for that? Gentlemen, you've been doing so well. Stay strong. What is the x value there? 0. There is one more answer to this. What is it? Is there anywhere else on the black curve where the y value is 1?
Yes.
Where?
Right there.
Right there. So what's my other value there? -4. Nice. Where do I go for E? Is that a y or an x value? It's a y, and it equals 3. So where do I go? Up to down to -3, or no, +3. And then I find the x value. Where is it?
Right there. There we go. There we go. Dude, I was looking through the thing. I was like, oh,
Is everybody cool? Okay, you guys do F and G. Go. I'm going to erase all this, and then I'm going to see if you're right. Do not yell out an answer. Let everybody have a turn. Even though half the people aren't going to do it because a bunch of them are on their phones and stop paying attention. Then they can complain to me later about how they don't get math. I'm not going to tell you yet because I'm not done. I'm going to wait another 10 seconds, which should be enough. Done. Where do I go? Out to 4. And do I check on the curve or the straight?
Down the straight.
The straight one. What is it?
-2.
-2. What do I do here?
You go to -2.
-2. And what do I find? -1 and -3. Everybody cool? All right. Your homework tonight is page 167, but wait.
There's more.
There's more.
Wait.
Are you gonna say that we don't have
Oh, God.
I want you know it looks big, but there's lots of pictures.
Oh, sure, yeah. That's
There's tons of big pictures. They take up a lot of room. Wait. Wait. Remember, you don't have to do all of it. You just need to do enough to get it. You've got the answers. You be your own judge. But if you think you've got it, I want you to do this. Write this down. F of x equals 3x plus 5. G of x equals 5 minus 5 minus, okay, 6x. I want you to tell me
The answers.
the G of the F of 5. Not saying anything more. You told me you got it. If you get it, that's no problem. Go. It's on YouTube.